Hey everyone, Nimble here. Welcome back to the channel where we uncover the fascinating secrets hiding inside your everyday tech. Have you ever wondered what really makes your TV turn on instantly, or how your phone charger keeps your device safe from power surges? It might seem like magic, but it's actually thanks to a tiny yet mighty component called a capacitor. Capacitors are everywhere, hidden inside your laptop, your gaming console, and even that smart toaster sitting on your kitchen counter. They're in almost every electronic device you use, quietly doing their job. These little components are the unsung heroes working behind the scenes, making sure your gadgets run smoothly, efficiently, and reliably, day after day. Take your camera flash, for example. That blinding burst of light you see when you snap a photo? That's a capacitor in action, charging up with energy, then releasing it all at once in a split second to create that powerful flash. Without capacitors, your electronics would be sluggish, unreliable, or sometimes wouldn't even work at all. They help stabilize power, filter out noise, and keep everything running as it should. Today, we're pulling back the curtain to reveal how these tiny components make such a huge difference in our daily lives. Understanding capacitors is like unlocking a superpower. It lets you appreciate the genius engineering packed inside your favorite devices, and maybe even fix or upgrade them yourself. Don't worry, we'll break everything down with simple explanations and fun analogies. No confusing jargon or complicated math, just clear and easy to follow info. By the end of this video, you'll know exactly what a capacitor does, how it works, and why it's so important. You'll be a capacitor expert, ready to impress your friends with your new knowledge. So, are you ready? Let's dive deep into the heart of your electronics and discover the amazing world of capacitors together. We'll explore what capacitors are made of, how they store and release energy, and the different shapes and sizes they come in. Plus, I'll show you how to handle them safely, so you can tinker with confidence. Let's get started. So, what is a capacitor? Imagine a tiny water tower. Your city's water tower stores water for sudden demand. A capacitor does the same for electricity. In a circuit, the battery is like the main water pipe, and the capacitor is the tower, slowly filling up with charge. When a device needs a quick burst of power, like a camera flash, the capacitor dumps its stored energy instantly. This ability to charge and discharge rapidly is its superpower. Capacitors smooth out power, filtering electrical noise, and providing stable voltage for sensitive components. In short, a capacitor is a super-fast, rechargeable energy reservoir. Unlike batteries, they release energy almost instantly. This simple store and release function is a building block of all modern electronics. From radios to supercomputers, these tiny water towers keep everything running smoothly. How does a capacitor actually store electricity? It's a question that might seem simple, but the answer reveals a fascinating world hidden inside even the tiniest electronic components. Capacitors are everywhere, from your phone to your car, and they play a crucial role in how modern technology works. At its core, a capacitor is basically a sandwich, two metal plates separated by an insulating layer called the dielectric. This structure is deceptively simple, but it's the foundation for how capacitors work. When you connect a capacitor to a battery, something interesting happens. One plate starts to collect positive charge, while the other gathers negative charge. This separation of charge is what allows the capacitor to store energy. The dielectric in the middle keeps the plates from touching, preventing a short circuit. Instead, it allows charge to build up on each plate, creating a kind of electrical tension. But the dielectric isn't just a passive separator, it actually boosts how much charge the capacitor can hold. The better the dielectric material, the more energy the capacitor can store for a given size. That's why capacitors come in so many varieties. Some use ceramic, others use plastic films, and some even use special chemical pastes. Each material changes the capacitor's capacity, or how much energy it can store. The size and distance between the plates also matter. The closer and larger the plates, the more energy the capacitor can store. Engineers carefully design these factors to get the right balance for each application. To fit more surface area into a small package, many capacitors are rolled up like a jelly roll. This clever design lets them store more energy without taking up extra space on a circuit board. The real magic happens in the space between the plates. The energy isn't stored in the metal itself, but in the electric field that forms in the dielectric. This invisible field is where the potential energy waits, ready to be released. Think of it like stretching a rubber band. The more you stretch, the more energy is stored as tension. In a capacitor, the electric field is that tension, holding energy until it's needed. When you disconnect the battery and provide a path for the energy to flow, the stored charge rushes out in a quick burst. This is why capacitors are great for things like camera flashes or smoothing out power in circuits. That's the discharge, the snap of the rubber band. It's a simple concept, but it's the secret behind some of the most powerful and essential functions in electronics. On a circuit board, capacitors come in all shapes and sizes, each one designed for a specific job. Whether you're looking at a tiny gadget or a massive industrial machine, you'll find capacitors working quietly behind the scenes, making sure everything runs smoothly. Ceramic capacitors are some of the most common types you'll see. They're usually small discs or rectangles, and they're perfect for filtering out high-frequency noise that can interfere with signals. You'll find them sprinkled all over circuit boards, keeping things stable and clear. Electrolytic capacitors, on the other hand, look like little cans standing upright. They're easy to spot because of their size and shape. These capacitors can store a lot of charge, making them essential for smoothing out power supplies and providing bursts of energy when needed. But be careful, they're polarized, which means they must be connected the right way. If not, they can leak, fail, or even explode. Film capacitors are another important type. They're known for being reliable and precise, which is why they're often used in audio equipment. If you love crystal clear sound, you can thank film capacitors for filtering out unwanted noise and distortion. Then there are supercapacitors, also called ultracapacitors. These are the giants of the capacitor world, capable of storing huge amounts of energy and releasing it almost instantly. Supercapacitors are used in electric vehicles to provide quick acceleration and in emergency power systems, where a sudden burst of energy is needed to keep things running during outages. Each type of capacitor is like a specialized tool in an engineer's toolkit, chosen for its unique strengths and abilities. The right choice can make all the difference in how a device performs. When the right capacitor is used, your gadgets run more efficiently, reliably, and safely, often without you even noticing. From tiny ceramic discs smaller than a grain of rice to massive electrolytic cans as big as your thumb, capacitors are everywhere in the world of electronics. Next time you open up a device, maybe a remote, a speaker, or even your computer, take a closer look at the circuit board. See if you can spot the different types of capacitors hiding inside. They may be small, but they're the unsung heroes of electronics, quietly making sure everything works as it should. Up next, let's uncover how to read their secret codes and truly understand what makes each capacitor unique. Found a capacitor covered in numbers and letters. It's not as mysterious as it looks. The key value is capacitance, measured in farads, usually microfarads, nanofarads, or picofarads. Big electrolytic capacitors have values printed right on them, like 470 mW at F25V, meaning 470 microfarads, max 25 volts. Always use a voltage rating higher than your circuit's voltage for safety. Small ceramic capacitors use a 3-digit code. For example, 104 means 100,000 picofarads, or 0.1 microfarads. Letters like J, K, or M show tolerance, how accurate the value is. J is plus 5%, K is plus 10%, M is plus 20%. For most uses, tolerance isn't critical, but for timing circuits, precision matters. Decoding these markings helps you pick the right part for your project. It's like reading a secret recipe for your electronics. Once you know the code, you're in control. Let's see where these little guys actually go. Where do capacitors actually work their magic? First, power supply filtering. They smooth out bumpy DC voltage so your devices get clean, stable power. In timing circuits, capacitors and resistors create predictable delays. Think blinking LEDs or computer clock signals. They're also used for signal coupling, passing AC signals while blocking DC, like in audio circuits. Decoupling capacitors sit right next to microchips, providing instant energy for fast calculations and preventing voltage drops. And for the big jobs, camera flashes and defibrillators rely on capacitors to deliver huge bursts of energy in an instant. From subtle filtering to life-saving shocks, capacitors are everywhere. They're the backbone of modern electronics. Next time you use a gadget, remember the tiny capacitor working behind the scenes. Let's talk about staying safe around them. Safety first. Capacitors are powerful, and sometimes dangerous. Large electrolytic capacitors can hold a lethal charge even after unplugging a device. Always discharge capacitors before working on a circuit. Use a resistor-based discharge tool for safety. Never assume a device is safe just because it's unplugged. For electrolytic capacitors, watch the polarity. The negative side is marked, and connecting it backward can cause leaks or explosions. Always double-check before powering up. Respect the voltage rating. Using a capacitor below its rated voltage can cause it to fail, sometimes violently. If you replace a capacitor, match the capacitance, and use an equal or higher voltage rating. Safety isn't optional, it's essential. Treat capacitors with care and you'll avoid nasty surprises. A little caution goes a long way. Now let's look at common mistakes to avoid. Stay sharp. Let's cover some common mistakes beginners make. Using the wrong type. A slow electrolytic in a high-frequency circuit won't work. Use ceramics for speed. Overheating during soldering can silently kill a capacitor. Be quick and efficient with your iron. Misreading values. Don't confuse 103 with 104. Double-check and organize your parts. Placement matters. Decoupling capacitors must be close to the chip they support, or they lose effectiveness. The physical layout is as important as the schematic. Avoid these pitfalls, and your projects will work reliably. Now, let's wrap up what we've learned. Let's recap. Capacitors are the hidden powerhouses in your gadgets, storing and releasing energy in a flash. They're simple sandwiches of metal and insulation, but they enable everything from smooth power to camera flashes. We learned to read their codes, respect their safety rules, and choose the right type for the job. Understanding capacitors unlocks the secrets of modern electronics. Next time you use a device, you'll know the tiny heroes making it possible. With this knowledge, you're ready to tinker, build, and invent. Thanks for joining me on this deep dive. See you next time.